Section 1. The thirst for power. Turbochargers versus superchargers. Turbochargers and superchargers are forced induction systems that boost internal combustion engine power by compressing intake air, allowing more fuel to burn and increasing horsepower, often by 50% to 100%, without enlarging the engine. It crams more air into the engine so you can burn more fuel and make more power. Like giving an athlete extra oxygen for an explosive burst. More air, more fuel, bigger bang, more horsepower. The quest for power is as old as the engine itself. You can make engines bigger, or make them breathe better. Forced induction lets a small engine sip fuel at cruise, then snarl on demand. The turbocharger and the supercharger share the goal, but take fundamentally different paths to get there. It's not just about peak horsepower, it's how power arrives. Smooth and linear, or delayed, then all at once. Forced induction shapes sound, response, curves, and efficiency. By the end, you'll know which feel suits you, and why. Most engines breathe naturally, relying on atmospheric pressure. Intake, piston down, valve open, air rushes in, air mixes with fuel. Then it's compressed, spark ignites, making the power that turns the wheels. Exhaust out, repeat, thousands of times per minute. The limit? Ambient air, about 14.7 psi at sea level. You can't fit more than the cylinder displaces without help. That caps fuel burned, and caps power. Forced induction changes the rules by pushing air in under pressure. 7 psi of boost can add roughly 50% more air. More oxygen, more fuel, more torque, and a lot more grin. A turbo makes power from waste. Hot exhaust spins a turbine. The shaft links turbine to compressor, often past 200,000 RPM. The compressor packs air denser, often cooled to prevent knock. It's energy recycling, waste turned into usable boost. Because it doesn't draw from the crank, it's efficient and everywhere. A downsized Turbo 4 can match a bigger V6 while sipping fuel. The trade-off is lag. At low revs, little exhaust means little boost. Rev it, and it wakes up. Then the rush hits. Engineers fight lag with twin-scroll housings, variable geometry turbines, and smaller responsive units. Modern turbos feel seamless, yet a hint of lag remains part of the character. Efficient, compact, powerful. Turbos turn waste into speed. Superchargers are straightforward, belt-driven by the crank. Press the pedal, revs climb, the blower spins, no waiting. Different designs, same mission, pump more air right now. Roots units move big low-end air for instant shove. Centrifugal acts like a turbo's cold side, scaled by engine speed. The result is immediate, linear boost, predictable and addictive, perfect for street digs and drag racing. Downside? Parasitic loss. The blower steals some power to make power, sometimes as much as 20%. That hurts efficiency compared to a turbo. But packages simpler, cooler, and often easier to install. And that's signature whine, music to some ears. Superchargers make a car feel like a bigger naturally aspirated engine. Instantaneous, visceral, mechanical, power on demand. The big split is energy source, exhaust-driven turbo versus crank-driven supercharger. That single choice dictates response, efficiency, and application. Supercharger, instant, linear, turbo, reduced lag but still a ramp. Efficiency crown goes to the turbo, recycles waste energy. Superchargers excel at low-end shove and response. Turbos often win on top-end horsepower. Turbos add heat and plumbing. Blowers add belt load and weight. In short, turbo for smart efficiency and big numbers. Supercharger for instant, predictable punch. The right choice depends on what you value behind the wheel. Instant response, efficiency, peak power, ease of install. Want the sophisticated high-tech surge? Turbocharger is your pick. Crave raw, immediate torque and drama? Supercharger is calling your name. Both thrilling, delivering speed in profoundly different ways. Pick the character that makes you smile every drive. Choose your boost and enjoy the ride.